Hello student, welcome you all again in our YouTube channel Electrical Study. Now today we will see how we can solve example related to the transformer, and we will use different formulas that we have derived in our previous video. Just to recall it, these are the notations we can use during the solution of example. Let's see problem number 1. If we read the data, primary coil and secondary coil number of turns are given. Sometimes loops are also used as a word for number of turns. So 500 and 5000 are NP and NS respectively. Input voltage is also specified 220 volt. So as per our relevant notation, that is VP. So first of all, we have to identify given parameters. It will help to easily apply formula relevant to the unknown parameter. What is unknown or what is required to find? Output voltage, that is secondary voltage, Vs. So from this we can easily observe the relevant formula we can apply is Vs by Ns equal to Vb by Np. This formula helps us to calculate value of Vs as a 2200 volt. Likewise, for other kind of data, let's say which is specified in a task also, transformer has primary voltage of 230 and turns ratio of 5:1, calculate secondary voltage. So using the same logic, one can find answer for the given task. Same way, example number 2. Again here, number of turns for primary and secondary are given. So NP and NS are known to us. Primary current is given as a 4 ampere. So IP is known to us. Current in a secondary coil is required to calculate it. So IS is unknown for us. For this given data, the relevant convenient formula is relation between current and number of turns. Using this, we can find unknown value Is as a 4.4 ampere. It means depend on the data, we have to select appropriate formula from the derivation. Example number 3, which is based on this figure where N1 N2 ratio is given with value 11:1. Secondary voltage is given as 24 volt. So this is our known parameter. Unknown or the wanted parameter to be calculated is what? Primary voltage Vp. So from the given data and the required data, we have to find suitable formula. So this is the suitable formula. Vs and Vp are known to us. Ns, Np relations are there and Vp is unknown. Vp is unknown for us. So that's why by solving this formula, we can easily calculate Vp equal to 264 volt. So depend on the situation, depend on the data, appropriate selection for formula is required. Move for the fourth part. The voltage ratio of single phase 50 Hz transformer is 6000 by 500 volt at no load. Calculate number of turns in each winding if the maximum value of the flux in core is 7.82 milliweber. So these are the known parameters. Remember, for no load, E1 will be equal to V1 and E2 will be equal to V2. So these are the known parameters. Phi maximum is also given. Frequency is specified in data, but the unknown are number of turns in each winding. It means N1 and N2 are required to calculate. So from the data, we need to observe about convenient equation that we can use. So from this, We can select E1 equal to 4.44 F5M N1 formula for the calculation of N1. This is the rearrangement. All the data are specified. Place it and we can calculate N1 as 3456. Sometime based on the data you may find fraction number, but remember number of turns we generally take as an integer number. That's why this is the integer number 3456. And still N2 is required to calculate. No required to go for further calculation in this way, but simply by using turns ratio we can find N2, that is number of turns in a secondary, as 288. So likewise transformation ratio, turns ratio and EMF formula can be used for the different kind of example. 10 kVA rating is specified for transformer in example number 5. Ratio of voltage 3300 by 220. Single phase 50 Hz transformer has EMF per turn equal to 10. Remember this is EMF per turn. And we need to calculate N1, N2, maximum flux and current in both winding. So let me start to solve this. Given data are transformer rating in term of kVA, that is 10. E1 is specified 3300, E2 is 220 and EMF per equal to 10. To find out N1, I will use this formula EMF per turn into N1. Using that all the data are known to us and it is easy to calculate N1 as 330. Same way for N2 calculation, that is 22, using this same kind of formula. For 5M we can use equation for E1. Except 5M all the data are known to us. So using that we can find value of maximum flux. Now to calculate current we can use relation between voltage induced, current and rating of transformer. So this is the relation. Either we can say VA equal to V into I or E into I, or we can say kVA equal to VI by 1000. So here VA we have convert this given kVA 10 in a VA form. So 10 into 10 raised to 3 upon E1 will give answer for full load current in a primary winding. Same way for current in a secondary winding. Remember power rating will not change whether winding is primary or secondary. So in both formula VA is 10 into 10 raised to 3. Likewise we can calculate unknown parameter from the known parameter in case of the transformer using EMF formula, turns ratio formula and transformation ratio formula. Thank you guys.